All right. We are live. Welcome to another This Week in AI. Very exciting week at the moment. GTC is going on. Our normal co-host is unavailable. Big wigging with Jensen, I'm sure. We've brought in Ricardo, who's another principal here in the London office. Yeah, Ricardo, do you want to introduce yourself to the people on the maybe watching the show?
Hello. So my name is Ricardo. I've been with Thoughtworks for 2 years. I'm a principal data architect here. I'm having a lot of fun working with Ben from time to time. Welcome to the show. It's a pleasure to be here, by the way.
Absolutely, yeah. So Ricardo is another one of these people who I bounce these ideas off and always gives me a lot of really good feedback, good insight. So very excited to have him on the show, and maybe the first of many. You never know. He's also secretly excellent with AV, which is a massive improvement. You've given me a lot of advice on the audio setup as well. So not just technology. He's an expert in many domains. Cool. So as always, we've got a lot to get through, we'd love to see your comments, feedback. So please, make sure that you are commenting, and we should see your comments come up real time. That'd be great if they can. So let us know if you have questions about the things we're talking about, and we'll try and respond to them. It makes it a lot more fun, interesting, and interactive. Please do. Right. So first bit up, bit selfish, but we've got chapter 3 is now out. AI platform building blocks in pre-release. Please, go and check it out. I love this quote that we started it with, like, when a new building block is discovered, the result is usually a range of innovations, and that for me is what generative AI is, right? It's another building block. So gives you all of that combination of other bits and pieces. So little plug at the beginning. Go check it out. Let me know, and feedback very welcome.
And relevant for today's content, right? The whole building blocks, because we saw significant steps in that area just on the agentic platforms.
100%. So sort of hardware side, NVIDIA have already sort of talked about this. Like new chip via like for full scale production AI factories. So I've not
factory in a box, right?
Yes.
Factory in a box.
Yeah. So looks like any other rack, but again, is for sure like up in the stakes here, and so again, 7 breakthrough chips, 5 racks, 1 giant supercomputer. So it seems like this is just again another big increase, right? And again, probably worth highlighting the work they've done with Grok with a Q, not Grok XAI's Grok model, Grok with a Q, the inference company, who again had some innovations in terms of inference speed. So this was a collaboration with Grok that they've done. So getting a lot more throughput, really, of
the inference startup, right? It's amazing how a small company can have such an impact on this disruptive field, and having a startup already contributing to this is amazing. And I think it proves a bit that they are also leveraging a lot of AI to do these things. That's how they're accelerating so much. So they announced not only this one, but they are already announcing the next one. So the next one's going to be Rosa. It's called Janeman platform, and it's going to have a Rosa CPU. So it's really cool that it's named after Rosalind Franklin that contributed to the DNA thing. Amazing how they're like they already have that view 2 steps ahead, right? So it's not just the next one; it's 2 steps ahead from now. Insane.
Yeah, I mean, I suppose that's part of that difference between the sort of hardware and software innovation cycles, right? You can just push software live very quickly and easily, but with physical hardware, there's just that extra
It takes
step,
time.
yeah, of sort of getting up to production, like actual like producing the chips at pace and speed, right? And again, like these are very high, very bespoke manufacturing processes that are used in these things. So each one is like configured from scratch, which is quite cool. But also, I
Sam
saw a guy.
Altman
Oh
Sam
yeah,
Altman said that NVIDIA infrastructure is the foundation that let us keep pushing the frontier of AI. So there's a symbiosis here for sure between hardware and software. Well, that's why NVIDIA is the biggest company in the world right now, right?
yes, yeah, exactly. Cool. So not just hardware, but also an approach to I'm not sure if this, but yeah, a way of hardening open claw.
I like your advertisement.
I know this is wild. Oh, that's quite small from Dean. But yeah, morning. Just installed Fedora on an old Intel. Going to set up with
Nook.
OpenClaw or Llama Cloud. Convince me this is a good idea. Yeah, Dean. Firstly, I think Dean's made every single of these, which is amazing. So thank you for always coming and commenting. Let me see if we can make your comment a little bit bigger. But there you go.
I would say it's not a good idea to put your passwords there and things like that, but it's definitely a good idea to play around with it.
Yes, I think so. I
It's
think it's
the
worth doing that.
what the it called it the Linux of agentic computing, right?
Yes.
Are
Yeah.
now are now overlord from NVIDIA,
Well,
which is
that's what I was gonna. I don't think we'll be able to get to the video bit, but I was watching the piece, and it was quite funny because he's like, "Yeah, it's great. It's got cron," and I was like, "Right, well,
yes.
this is the thing. It's like it's useful to have that. It gives you that feeling like it's always on, but yeah, it's just cron under the hood and a heartbeat every 15 minutes, and like a tuned experience and a very well connected one and a very personalized one that makes it feel like a very different product experience. But the sort of technical piece under the hood is like, I suppose, yeah, like a lot of people, I suppose more have been scared to put those capabilities together rather than like weren't able to put those capabilities together.
But
And
they addressed that. They addressed
yeah,
that, the scary part, because I think when he spoke about the Linux of agentic computing, and I have strong feelings about this, I think he meant the way that Linux was for Unix. By the way, cron came from Unix, not Linux. But which is it's the foundation, it's the kernel, right? Well, GNU Linux, but it's Linux is the kernel, and GNU is the thing around it that allow you to build all of these things and just created this amazing ecosystem. And what they're doing with OpenClaw, if you notice, is that they say, oh, NemoClaw goes on top of OpenClaw, right? To make it, enterprise ready, to give you the guardrails, to give you the sandboxes, to to give you the security. So what they're doing is you're no longer running OpenClaw. You have NemoClaw to make sure that like Dean, you don't mess up even if you put your passwords there, or it won't let you put your passwords there. Things like that. So I think the play from NVIDIA is interesting here because it's basically taming the madness of OpenClaw in a way that companies are, maybe more okay to use it.
Yeah. Though I also I would say like good tools are often sharp tools, and you can often cut yourself with sharp tools. So, like for it to be powerful and useful, for it to do great good, it can also have the potential to do great bad. So even with these things, it's like it's got the guardrails. There'll be one time when
Yeah,
you'll be like, yeah, well, I actually do want it to do this, and
yeah.
then you may have that piece of
It's a security. It's there's a very sharp edge there, right? But you
yeah.
put security in place so that if you make a mistake, you don't get cut. I think it's also tangential, right? And to the movement to my computer, sorry, personal computer, from perplexity and things like that, where we are moving into this, the crossover from just having a chat with an agent, with an LLM, to actually having an assistant, a physical, well, not a physical, but a virtual assistant in a way, almost
Yeah.
physical. If you when we're going to talk more about that with Manus desktop and things like that, and my computer.
Yes. Yeah. So super interesting. And I think I find no, that's Manus. There was also something I shared from giving Carpathy the new like desktop. But yeah, so
Oh
NemoClaw,
yeah.
I would say, yeah, give NemoClaw a go, see if the guardrails are good. And then also you can actually get a I think 3 do a SIM only thing. So you could get a completely separate phone number, completely
Mm.
separate email address, and then tie them up like kind of for free, and then do that. Exactly that. Like step by step adaptation of skills, very limited scope. Yeah, I think that's a good way of doing it. Progressively like expand what you're confident with, and over time, like if you feel like you went too far, then you can always cut back on those privileges as well. So it's just about being conscious of that stuff. So give it a crack. Nice. So along with that, at GTC, they were also announcing an extended collaboration with IBM. So yeah, you were talking about there's some interesting parts of this that you looked into, right, Ricardo?
Yeah. He said I shared the link with you, from LinkedIn,
Oh
that
yeah,
has the slide. I'll share it again. Um,
this one. Okay, sorry, wrong one.
yeah, that one. Well, and if you look at into the slide, you have like the. It's cool because you have open source stuff in the middle, the cloud provider stuff on the left. He called it its best slide,
Yeah,
and they're partnering not
definitely
only with
an
IBM, they're
engineering
partnering.
slide, not
Yeah,
a marketing slide.
yeah, definitely, and they're partnering with IBM, with and with others. And it's talking about structured data, and how structured data is basically what he says, the ground truth of AI. The
Mm,
what NVIDIA is saying is that they're gonna use their well, graphic engines, GPUs, to accelerate processing um, of this structured data. Nestle
mm,
did something like that. So they use, I think that they accelerated, I think it was Presto, using, Watson X Presto engine,
yeah.
83% cost saving, 30 times price performance improvement. Just by using GPUs to process data on Presto, which is a very well known technology in the big data space. So came from Facebook, I think.
Mm.
So amazing, this one. I love to see the crossover towards data engineering, as a way to create better AI. It's really cool.
I think that's the thing, right? We talk about like intelligence, knowledge, and wisdom, right? And it's just like a lot of the reasoning stuff, like it relies upon having the right information at the right time. Like if you don't have the right information at the right time, you can be wise, you can reason about something a lot, but you will make incorrect decisions based on the lack of information. So getting that information to the point at which that those decisions is being made, whether that's a human or an AI agent, is like critical for actually making good decisions. So yeah, 100% agree with this. We actually at QCon we also had some really interesting talks from a couple of people who are also building ontologies on top of their currently unstructured data and moving it over into this sort of structured piece. So large scale, like for Netflix, we're talking about what they did with turning their telemetry data into an ontology, which then allowed them to reason about their production system, which was super cool. And so they had like something like a pipeline of like, again, it's a big data engineering problem because of the volume of scale of the number of microservices they have and just the scale of Netflix. They had like something like, I think 65 million concurrent streams for the Jake Paul fight the other time. And, so getting all that telemetry data is like not just like a computing issue, it's a big data issue. And so then structuring that into an ontology allows them to reason about it at a level above the log level and, then work out where and sort of triage and try and find these bits and pieces. And so, yeah, that was super interesting. And then Neo4j did something around actually something very similar to the accelerator and the project that Ricardo and myself are working on, which is around like understanding unstructured data, modeling it into ontologies, and then building out and hydrating it into a knowledge graph so that you understand what's going on in different bits and pieces of content, which you primarily would have just had sort of like a kind of tag-based approach, or you'd have built an ontology by hand. So some interesting stuff going on there.
On this, I'm just happy that on this hype cycle we are no longer advocating for throwing everything into a data lake and saying you don't need to worry about structure. I do think that there's still that bit like of unstructured data. It will exist, but I think it's nice that they are focusing on the structured bit. Like possibly even Presto is an engine that can deal with unstructured data, but they're already calling it structure because in a way, like what you need that structured data to go and feed the ground truth of AI. So all of this work around ontologies, around structuring the data, actually understanding that at the semantic level, it's very interesting because it I think you can leverage LLMs, and we saw from our ontology accelerator that you can leverage LLMs to do that, but you can also use that then to improve the quality of the outputs of other LLMs downstream.
Yeah, exactly. And they actually had some very compelling slides on the impact you get on improving RAG when you have structured data.
Actually, I would like to see those slides. We need. Please share.
I'll share them with you, and then I actually also got something else which I haven't shared. So let me see if I can find it from one of our other colleagues who is at GTC. But yeah, he sent me something on. Right. Here we go. So can I share that here? There you go. So there's the precision improvements piece slide from the Neo4j. 3 times improvement in retrieval precision with the basic approach, 4 times with additional ontology. 40% relative increase in retrieval precision on graph plus vector versus vector. So that was super interesting from them. And they actually have like a structured semantic layer architecture. So I again need to share all these with you. And then Art was sharing with me this. Can I move that across? Here is it. PyG rag. PyG dash rag. Yeah, so similar-ish idea, but using a GNN, PyG, to do this graph rag. So yeah, like quite interesting that they've also so he shared with me I don't know why I can't get the picture up here, but yeah, like super interesting to sort of see this stuff come back and be used and have provable improvement. And so they're using PyTorch geometric PyG, and I think to some degree that they've got some other inference going on, but like looks okay, cool, there you go. So so they are fine-tuning the model based on the graph that is built, so you get like the graph retrieval, but also the model tuned to the graph, so that it also is more likely to query the graph correctly. I don't know how well that would work at scale across the org, but for a specific example that isn't going to change too much, that might be like a really interesting way of doing things. Or for a platform, a really useful way of providing tooling to do this and examples of how to do this. So yeah, like some super interesting stuff there, like not just like models, big partnerships, big things. It's also like practical stuff that we can take away and start looking at from a practitioner point of view, and start building on. But yeah, again, it just reemphasizes a lot of what we say, which is like agents, you can't just slap them on top of a crap architecture and think that it'll fix it, right? You know, you need to actually improve the underlying data or business APIs so that they are usable and fit for purpose. You know, like you can get some distance with just slapping an agent on it, but like,
and costs, right? And costs. You want to have, you want to have the cleanest data possible to make sure that you're not paying for the processing of data that is not relevant for the task that you ask for, the output that you need, right? Like you pay for data in, you pay for data out, so you want to make sure that you control as much as possible.
Yes, exactly.
Shall we move to the next one?
Yeah. So Manus. Manus obviously made waves for being one of the first like thing that kind of showed us really what an agent could do, and like characterized by like long runs, and lots of tool calls, and rapid iteration. And now they're moving to the computer, and have this sort of Manus desktop app. So yeah, looks pretty cool. Again, probably something that would be very difficult to put on a work computer. Without
you can do both, right? You can do both. This brings Manus out of the cloud. But there are solutions where you don't actually need the computer. There's providers. I think Mind Studio is one of them, that you can actually have your computer in the cloud. On that one, I kind of like the Perplexity computer approach, which is a bit simpler. But yeah, the Perplexity made it hard. So there's Perplexity Personal Computer and Perplexity Computer. Personal Computer is just like Manus Desktop, my computer. And Perplexity Computer, it's just this way of running agents that was launched in February, right? General purpose digital worker.
Yeah. I mean, like the anthropomorphizing stuff, I think, really gets in the way of understanding what these things are doing. So, but yes, like I don't know, I don't know about you, but I don't. I really, it annoys me when I see these examples of like organizing my folders. I just don't care. Like,
I think it's
doing something interesting, right? No.
Yeah, but I think what this is doing. Remember, I said before. I think what this is doing, although it's
And
Uh,
what was it?
well, I lost the word. Sorry,
I'm talking
but
optimizing.
I think that it is shifting the paradigm. Right? It's no longer you're interacting with a chat agent and you're getting information. It's
Mm,
the sense is you basically you have a digital worker
yeah.
that's doing things for you. You command it. I was having a very interesting conversation this morning about around it, which is okay. So people don't trust AI that much, and they're concerned about how much accurate this is. But if you have an assistant, I don't. But if you have an assistant and you ask your assistant for something, if even if your assistant is a human, the level of quality that you might get depends on how good your assistant is, right? Being a human or being an agent.
Mm,
So I think that people um, will get used to the stochastic way of it
yeah.
working because, like, that's how humans also work, right? You cannot
It,
get
it it tends
perfect
to fail in
outputs.
very human-like ways. Yeah, I agree. Um,
But
uh,
I think this is just I actually don't like that they tie it to the concept of computer, the actual concept of computer. I think it's much more related to the original concept of computer, which was a person that would do computation, right?
mm,
And I think that is better. I wouldn't show organizing folders because that's not what you ask your assistant, right? You ask your assistant to
well, yeah,
schedule
exactly.
meetings or manage your diary or um, I don't know,
Well,
like,
that's yeah, it's a good point. Why would I, if I can just have a conversation, why would I want to see a file system? Do
yeah,
you know what I mean? Like, like get me that photo. I don't care that you've named it correctly or organized it diligently.
mhm.
I just want the photo that I've asked for or the PDF I've asked for or whatever, right? Like, so yeah, I get you. I kind of agree. I also, by the way, had no idea that they'd been acquired by Meta. Um,
Oh, that's
yeah,
interesting.
yeah. So that like that turned. I mean, obviously I know why. It was in the middle of a 4-week holiday, so I had no idea about this. But yeah, that's
At
pretty
the
cool
same
as well.
time, Meta is not going. It's not very famous in terms of like their own agents. They're not going very well, right? They're talking about they're
Well, so
talking
they,
about
they
about layoffs, and that might be related to the quality of their agentic solutions. Maybe acquiring Manus is a way to diversify and not be 100%.
yeah, so they obviously had a big investment in Llama, but they haven't released a model in a while. They've delayed it apparently for I think it was like safety and like not hitting the quality that they wanted to. So yeah, like and of course they had Jan LeCun leave as well in a sort of disagreement around um, the model architecture, right? I think he was just basically like, yeah, like LLMs are great, but like you're taking all the flops to do inference on LLMs rather than research on other architectures. And
There
so
was
yeah,
there
that's
there were news about that this week, right? Do you have it? Yeah, that one, right?
yeah.
It's interesting that Sam Altman is saying that at the same time he's saying that the current architecture is probably not what's going to push us forward. And there's another one which was, I think I have it here. Um, can LLMs be computers, right? From Christos.
Yes, yes. So this is yeah. So this is the yeah. So it's basically right. So yes, like Zuckerberg's delay of Meta's latest model, Musk's recent admission XI was not built right. Has been no longer on board. So that's Kavara right? Everyone's talked about Transformers not being it, and then Perceptor, this company, have put it basically like WASM into the model like
Into Transformers, right?
yeah, into the transformer. Yeah, so it's still a vanilla transformer apparently, but it's also got this is super interesting. I've like only briefly scanned through this because it came out
But are we basically
quite
saying
a
now
while.
that a transformer is like Turing complete and you can execute things inside of it? Is that what it means?
Yeah, 100%. So this is the
Wow.
current paradigm, right? Of like, the model outputs this, and then the model, the agent framework will execute this and return it back, the output. So yeah, they've implemented WebAssembly interpreter inside the transformer weights, and like, low level instruction set. So they write this sort of stuff, it outputs this sort of tokens, then switches to the fast decoding and executes the program itself step by step within the transformer.
So this means we're going to have models that can actually do math instead of like faking it.
Yeah, and the other thing is, of course, is that because you aren't skipping things over into different processes, to like spinning up your code execution, all that sort of stuff, it's way faster. So the in model like execution becomes this. And yeah, so this demo for Sudoku is long horizon computation. And yeah, like they got 100% accuracy on the benchmarks, which is wild.
Well, it's a computer, right? Like the moment
Yeah.
it becomes a computer and not probabilistic, then you're expecting 100% accuracy, right? Because you're executing
Well, but
code.
then you can still have algorithms that just are like so like yeah, it could be Turing complete, but it's not going to track
Well,
like
but
take SHA encryption quickly.
yeah, but
Do
a
you know what I mean?
Sudoku solver, it's math. You expect it to be
Mm,
able to be 100%
yes,
accurate, right? Because
yes.
you either solve Sudoku or you don't, right? It might be slower, right? But if it's but I don't I'm not even sure if solving Sudoku is NP complete or something. But if it might be slower, but you still get either you get it or you don't, because you can literally verify your solution because it's a computer. By the way, on verifying solutions, maybe we want to go through that one of formal
Yes.
methods.
Yeah. So, well, we're halfway through and halfway through, so we shouldn't jump ahead too much because
Don't
there's still
rush.
some
Okay,
interesting
okay.
stuff here. There's still some interesting stuff here. So, the other way that they sped this up was to not go through the normal token attention mechanism, and they simplify it, and that makes sense, right? Because for the execution of instructions, you don't need to know about all the previous instructions by design. Whereas attention, of course, is producing tokens based on all the previous tokens in the token window. So they switch this to a much much finer grain, so 2D attention they call it. So yeah, and they give you the code in PyTorch, which is like
So
super
you lose the
interesting.
concept of history, the Markovian thing, or what came before. Is that it? You don't need that to execute code.
Yes, exactly, because you're just executing machine instructions and doing them one by one. So yeah, it's kind of like, yeah, you've got this much faster 2D attention, and you then end up like so again, I've not read this in great detail. Check this out
Mm.
in more detail, but because it's super interesting and I'm still kind of absorbing what it means. But yeah, that TLDR is the transformer has become a computer, and that
Dean brings an
allows.
excellent point about
Mm,
squeezing the most out of the current transformer technology, which we are, like when we're building computers on top of it. But if we shift away, from it, um, what happens? I think
mm,
I think we might get into a situation where if this becomes adopted in such a way that is widespread, when we shift away from it, there's still going to be, compatibility. Uh,
yeah.
uh, um, they're going to have to be compatibility layers. If it becomes a platform for computing, the next big thing will definitely have to be backwards compatible in some way.
Well, so this is the question, right? So at the moment, obviously, you have all of these tools that are implemented by the agent framework, which is software that we write around the um, uh, the LLM, right? Now, this is changing that paradigm, right? So I mostly consume AI via an API, right? So I don't actually have very much control about tools that I can't create a tool and put it behind the API. Right? So, and this shows that actually there's this massive advantage of having tools in the actual model. So then it kind of changes the whole structure of the conversation, because now I'm going to need to basically have this like training, or like, unless there's something that allows me to access these capabilities with software from the outside, like you said, with some compatibility layer, or some, like, when I call the API, I specify that I want it to use its computer and stuff like that. And I would suspect, given this has now been out for a week or so, like, Frontier Labs would have already been picking this up and will start to be. I mean, obviously, Perceptor AI is a Frontier Lab, but the massive labs that we talk about every week, they're going to be looking into this sort of stuff, and they will probably be implementing some of this, and it will probably be in APIs in 3 months or so. Maybe in the next big release of models, we'll have something like this that allows
So
that
you
sort of
think it's going to
computation.
be exposed as an API as well?
I suspect it will just be an option that you say, yeah, do I want this or not? But the issue with that is, like, this works for a generic tool, but if you or I were to build an agent and we wanted to add a more specific tool to our domain, to something like that, it's like, how do we do that if it's sort of, maybe we don't need to, maybe just running up, being able to
Wouldn't it
run
be
code makes
something?
sense.
Wouldn't it be like self-feeding, in a way that you, instead of like you deciding to use that particular API, you just ask the agent to do something, and it knows that it has that capability of creating that code. The same way that it leverages currently their own Linux or Bash environment. It probably knows that it can leverage itself and just execute that internally by programming itself, no? Instead of using an API, because that means that, like, I think that having an API where you execute code is giving you too much control about something like this. Why should it? Right? It's not what you want. You don't want it to use. You don't want to use it as a general compute. You want it to be able to compute things as you're going about doing some task.
So they kind of
Well,
talk about
it's like
that.
it's like when I ask it to do 3 + 5, like the example, right?
I, wait, does Rich have two things and he's commented twice, or is that like Rich and Choc Shows Away have exactly the same thing? Yeah, feels like eBPF for LLMs. That's funny. Yeah, like, you kind of but so eBPF is like a sandboxed kernel, right? So I don't know if it's actually spinning up even a, it's certainly similar in, like, conceptually, but I think it's more just like kind of like WASM, and so it's just got low level primitives able to execute in there. So it is explicitly used. So you could probably exactly the same as this, but with eBPF rather than WASM. I like is my We'll see if we can. I think it's fine. Don't worry, Rich. It's okay. I've done the same. But yeah, so it's got this idea, right, of growing AI systems like software. So if the software becomes part of the neural architecture, then the system needs a way to grow over time. So modern software, so modules, reusable components, similar process may eventually occur inside AI systems when new computational abilities are added incrementally to the model's internal execution engine. So this is super interesting. But then there's that question, right? Is that currently that paradigm of, like, like kind of cloud or like stateless APIs, if they're building their own capabilities, they're becoming to some degree at least stateful, right? And more a kind of OpenClaw like, right, where it builds its own tools, even though that's software, nothing on the model side. This is model side. If you've got like something that builds its own stuff in its own things, do you want that to be something that's more federated, right? So that actually, we have a model and we put it in a harness and an agent framework or whatever, and we expose it to certain things, and it creates the tools as it goes, and we prune the software that's inside its own inside the model, but that model is now we've kind of got like a 1-to-1 model to agent ratio, rather than currently where we've got like a cloud API model that doesn't change and is like deployed,
and you have the agents,
and then the agents, we've got many agents calling
yeah.
out to the same thing. So I think that might be something that you go, okay, cool, we're like,
but
I think
is
that's
it
very
that
exciting. Certainly for the ML engineers, this is very exciting, I think.
yeah, but it might just be like interesting, but not something transformative, in the sense that it might just be used to simplify execution of code, in a sense that you have, imagine you have like this infrastructure that is amazing at running model code, right, transformer code, and instead of like going outside of that infrastructure to run computation, you just run it inside your current infrastructure that's optimized for transformers. So maybe it's just that, maybe it's just you have in the model the capability to execute code. Oh, sorry, you have in the model not the capability to execute code, you have in the model actual programs that it can take advantage and never leave the model, instead of just having to go into another environment. So maybe it starts with that. It might expand in the future, but maybe for now it's just all of these, all of what came out of NVIDIA in terms of hardware, right? They're optimizing for this, for transformers, for it's all optimized for this architecture. So maybe leveraging as much as possible this architecture is what we need.
Potentially.
I don't know.
But
I'm not sure if it's
it's
a jump like we got from.
I don't know. I think this is quite transformational in a couple of different ways, but mostly I think it's in terms of like speed, token efficiency, and like
Saving someone's money, right? Not ours.
Yeah. So it's several order of magnitude cheaper and more efficient than tool calling and remote code execution.
Yeah. But it's still something that happens, at least for now, in upstream. We don't see it.
Yeah, but
unless
if you
we have that change in the API, which maybe.
Okay, but so let's like a sort of worked example might be you people are using LLMs to sort of narrate what is going on in like a self-driving car, right? It's not driving the car, but it's like reasoning about it and narrating it, right? It's like you could put some like ability to plan trajectories and execute that, and the speed of inference would make an entire like new way of looking at motion work now, where you've combined the reasoning and the vision in a way that actually kind of works. So that's the only thing I think. I think there's going to be a bunch of stuff that now becomes possible because you can do this like very low latency computation. And yeah, Rich is saying, curious how an infinite loop would manifest. And it's basically just like if you give something the ability to create its own software that it can run, that's your infinite loop, right? Where you can literally just like you throw problems at it and it can bring, like, I don't know if it's a good infinite loop. Like it might take infinity to to get to the end of the loop, but like it has that self-improving piece there, right? And you can demonstrate this with, I mean, you don't need this complexity to have that like self-improvement stuff. I think one of the things I haven't been able to look into yet, but it's like also research by Andre Karpathy. So like again, like frontier AI research being done on an agentic loop, with experiments, and yeah, like again, like a relatively simple program here, so you can kind of see like it's not a lot, like, which is why it's so great when Andre does this stuff, because it's like quick and easy to see what's going on. And yeah, so okay, cool, that's literally just the picture. But yeah, so what, this is 600 lines of like the torch training, and the data preparation, so one-time data preparation, 300 lines. So yeah, I think the whole bit of it is in here, where it's like self-improving itself over time and running a bunch of experiments and then improving them each time. So like people have adapted this to a bunch of stuff, but yeah, like you can get these infinite loops quite quickly. We have a kata that's a self-improving agent that writes its own tools in the similar sort of way to OpenClaw. And so you can get started on those loops, whether you end up in a place that's like hitting it, I don't know. But yeah, so
Yeah, maybe now you're writing those loops inside the LLM. Andre was super excited. He replied to Christo's tweet.
oh, did he?
Yeah. Wait, this is so awesome. Both the C compiler to LLM weights and the logarithmic complexity hard max attention, its potential generalizations inspiring. So that's always good when you tweet something and Andre, posts back. So good stuff there.
Right, what's the chap's name? Christos. Don't know why I wrote Christine. Yeah, so here you go. Here's the tweet, and then yeah, I presume it's one of these.
If you open the tweet, like I think Andre is one of the first ones. Yeah.
Boom. Awesome. Cool. So then again, this is coding, right? So I suppose a little bit of a jump over to sort of, again, a consistent theme around like AI coding being one of that premier frontier use cases. So yeah, there's a paper here by Meta. Shout out to Alejandro who highlighted this. But yeah, basically the thing is that actually benchmarks and SWE bench pass rates overstate real world coding usefulness, which we kind of narrowly talked about. Yeah, by quite a lot. Like if the model's SWE bench score is 60, does that mean it resolves 60? No. Like
half of them would not be merged.
Exactly, yeah.
Ouch.
So
and this and I was going to comment though, and maybe this is old stuff and LLMs have improved so much. Not really. This goes to late 2025, so the technology that they were using was pretty up to date. Frontier models.
Yeah, 4.5. Again, that's like relevant, and this relationship holds true, right? So again, but this is one of the reasons why they might have moved off from that to SWE Bench Pro and stuff like that. But yeah, like there's all sorts of other reasons around like kind of tests passing, which is like where this like stuff goes, and like the like there you go. So core functionality, code quality, breaks of the code, like all this sort of stuff that you can't really capture easily in the benchmark, that in the real world actually count quite a lot. So yeah, it's interesting to see. Okay, here you go. So automated grader, core functionality, breaks other code. So very little breaks other code, which is good. A lot on code quality.
Do you think this is Goddard's law, though? That the we that the agents are somehow optimizing for the measure of passing the SWE
Yes, yeah, 100%.
bench.
Yeah,
Do you
it's
think it
overfitting
is?
for sure. Yeah, the
Oh,
sweep bench,
that's
sweep
really
bench is
bad
yeah,
because then like they're doing these they're coding not for the usefulness of the of what was required from them, but actually to you know fit the SWE bench pass rates as well.
and I think yeah, like Sweebench are aware of this, and there's Sweebench Pro now, which is curated to fix some of those issues. But yeah, it's like highly oversaturated and appears in the training data. So now it's like
Oh,
a lot of stuff. But yeah, so yeah, I don't know if we want to cover this one. I like too much, but yeah. So there was an update to this. So this was like a vibe coding iPhone apps, and then yeah,
oh,
basically Apple
ouch.
has actually updated and said they don't have any rules specifically against vibe coding apps, but interpreted code may be downloaded to an application, but only so long as such code does not change the primary purpose. And so you can't like that's their code of contact, and
You cannot vibe code. That's what basic. I think all of those executives that say, "Oh, I can build the next," you know, uh, a startup doing an iPhone application without hiring software engineers. This is a bit of a wake up call for them that probably you still need people that know how to code.
yeah,
This
100%.
one and the previous one, right? Like this one and the previous one.
Yeah, for sure. And so yeah, one of the interesting things that we took away, I had a debate with Ian Cooper, and actually I met Martin as well, and
Oh,
had a chat with him about this, and he pointed me to his blog, which I'd sort of been like circling around some of these ideas, but as always, Martin's miles ahead, like, and yeah, he's made a prediction that AI will make formal verification, formal methods go mainstream. And he's got some really good reasoning here around this stuff. Because, firstly, like, actually, you can write this stuff with AI. So, yeah, here you go. Writing
so it
proof
makes it
scripts is one of the
easier.
best applications.
It
It
definitely
doesn't
makes
matter
it
that they
easier.
hallucinate because the proof checker will reject any invalid proof and force the agent to retry. And the proof checker is itself a small amount of code, making it virtually impossible to sneak an invalid proof past the checker. And so there's also a piece around like this making it more important to have formal proofs
Hmm.
because you're not going to necessarily view all of the code as much if you're producing vast volumes of code. This allows you to then create a specification and do that. And I think there was
Lean straw, right? Yeah, it was
uh,
that one.
yeah, I was going to try and find a paper that had oh no, I think it was just from here. Yeah, so he's looking at this paper for like benchmarking very coding, which I think probably could do with updating now already, but it's super interesting in terms of using these techniques actually to do stuff. And so obviously other people were listening, and because you pointed this out to me. So Leanstral, open source foundation for trustworthy vibe coding. Yeah,
That you cannot use to create an iPhone application, but because Apple doesn't let you,
no,
even
exactly.
if it's
Which was
formal verified. I remember in uni thinking, I'm never gonna use this formal methods for anything, and well,
yeah,
not proven wrong. It's
yeah,
gonna it's
absolutely.
gonna
Well,
become
potentially
mainstream,
it's
not
we'll
just
see, we'll
for
see.
airplane software.
But so yeah, you can see here, like definitely ahead of Kimi K2, GLM5, Quen 3.5. So these are big models, right? So there's 120 billion with I think A6B is active. So mixture of experts. So this is probably runnable on consumer hardware. Probably not necessarily, but so yeah, I mean, like high value alternative to the Claude, competitive performance at a fraction of the price. So beating Sonnet by
But wasn't
2.6.
this about formal methods as well? That's what I don't understand. Like, because I thought maybe
Yes.
I sent you the wrong link, or
No,
no?
no, no.
No, it's
So
reasoning about exactly. It's reasoning about programs. Okay.
yeah, so it converts it moves away from English into Lean
Okay.
and Rock Q.
I thought I know.
No,
I know lean. Yeah.
this is yeah. So Lean is the formal verification like syntax they're using.
Yeah.
And as you can see, really legible, human readable, very easy for us to. You know exactly what this means, right, Ricardo? So you
I
know.
learned it. I learned it. I think I failed the first time. I have to go through the course twice. Yes.
Yeah. I mean, yeah. So I wouldn't want to write this from scratch myself, if I'm perfectly honest. But yeah,
But
it
that's what
it
it gives you, right? Like this amazing era where we can use these tools to we can leverage these tools to do so much advanced you know computation and mathematics in this case. So formal methods are away from of mathematics. So
oh, nice. Oh, and yeah. So zero setup in Mistral Vibe. Okay, interesting.
nice.
Yeah, and you can download the model and run it on your own metal. So this is very cool because it's kind of like this this model here to some degree. Again, it's not fully Turing complete in that same way, but it's like fully open source, and you can download this and run it on whatever hardware you've got. So very cool. I'm gonna give that a try. Yeah, hopefully later today. Right, we've got 3 minutes. I'm going to rush through some of our other bits and pieces that we found. So, report on copyright and artificial intelligence.
That's an
This is
important one.
125 pages, but most of it is no change, holding pattern, which is fair enough. Like this stuff's changing all the time. A lot of the things like exception with odd out, an exception with an opt out was rejected by both copyright owners and also AI researchers. So basically, everyone hated it. And that was what they hoped was going to work. But yeah, the TLDR is there's actually going to be there's been legislation in the UK on copyright being available for computer generated works since 1988. I didn't know. But apparently that's being revoked. And so most of the AI assisted, AI generated stuff is going to be covered by like normal copyright now. So
Cool.
yeah, like, I mean, TLDR, yeah. This was an interesting piece on the still missing.
Oh, I like this one.
From
Yeah.
MCP. Yeah, Julian was great. He wrote about this a while ago. And yeah, I kind of agree. Like a lot of it's still missing. So this was the disregard for 40 years of RPC best practices. There's stuff going on with that. I saw a great talk from Anthropic about this sort of stuff. And they're doing some other bits and pieces on the sort of actor method and fine-grained permissions, which is interesting and what goes towards some of this, but again, not implemented yet. And then this was interesting as well from Apple, which was surface light field tokenization. So again, we can't go into too much. Oh, wait, I thought I had the publication up and the picture. But yeah, so pretty cool. I don't know. Do you want to say anything about this?
Well, yeah, I was looking at it, and it's super interesting because you go from just a 2D photo to a 3D model, which is something that you could do before, right? But the way it now works, it gets you both the object itself, the physical dimensions of the object and how it reconstructs it, but also keeping the texture, the highlights, the other things around the visual that makes it much more consistent, let's say. And it's amazing how it can get all of that from a single image. It basically, from what I understand from reading this very briefly, it separates the two, right? It separates like understanding what are the dimensions and then understanding the light and color and reflections. and
Mm.
then pulls all of that together. Super advanced stuff. I'm guessing that it has a lot of implications in how we model, how agents model or view the physical world. So we're getting
Mm.
there into like robotics and things like
Of
that,
course. Yeah,
right?
because you're
Because
basically, yeah, you're seeing something in 2D and then you're understanding that it's a 3D space. And so yeah, you have that. Ah, I
and
hadn't
it
even
showed
thought of
up.
that.
It showed up. Oh, so you know Olaf from, yeah, you have a kid.
Yeah,
Olaf from Frozen. It showed up in GTC, and it was all being computed in
yeah.
real time.
I made a post about it,
Oh,
and
I didn't saw. I didn't saw. Didn't see that.
and no, it fell completely flat. Like, yeah. So where was I? I was like,
Well, you
I
weren't
was like,
there, man.
no, I wasn't there, but I was like, come on, like, you know, if you tell me that doesn't look like Disney's about to go Skynet.
Yeah.
The
Okay, that's a bit
cutest little
scary.
Terminator you've ever seen.
Yeah. It- because that one doesn't melt, right? You cannot protect from that one. It's
No,
not
I
made
mean,
of
yeah,
snow.
2000 degrees centigrade, maybe it would melt, but
Yeah,
yeah, like
maybe. But still, it's like that. The borders, the edges are expanding towards the physical world in multiple ways. You know,
mm,
co- you know, controlling your PC, understanding the real world. Uh, uh, computing a real life animation that interacts with that real world. Scary stuff. Scary stuff. The
or exciting stuff.
singularity is getting closer and closer.
Mm. Yeah, sure. Like- but anyway, what an yeah, thank you so much, Ricardo. You smashed it. Like, yeah, some really interesting conversations, some good
Has been a
comments from the
pleasure.
people watching. So yeah, um, onwards and upwards, and yeah, we'll see everyone next week, hopefully. Ciao for now.